In this lesson, we are going to talk about sampling methods and good or bad ways to sample a population. So you'll see we have some vocab to fill out on the first page. I'm going to let you guys copy that down. So pause the video, copy this down, and then listen to me talk about it. So a population is the entire group of people or objects you're choosing from. So if I wanted to survey someone like the sophomores in our high school, my population would be all HHS sophomores. If I wanted to survey all students at our high school, then my population would be all HHS students. The sample is the subgroup of the population that participates in the study, meaning let's say that I want to sample all sophomores, like I said, in my population, and I'm going to sample, let's say there's about 200 of you, I'm going to sample 25 sophomores. So I would say the 25 that I survey is my sample, the 200 that exist in our school is the population. And then bias is something that sways results a certain direction, and we'll talk a little bit more about that as we go. So here is just a little piece of history, so I'll read it to you, I guess. A voter poll taken during the 1936 presidential election provides a good example of the danger of biased sampling. A magazine called Literary Digest sent a survey to 10 million Americans to determine how they would vote in the upcoming election between Democrat Franklin Roosevelt and Republican Alf Landon. More than 2 million Americans responded to this poll, and 60% supported Landon. The magazine published these findings, suggesting that Landon was guaranteed to win the election. So we'll talk about this as we go on in this lesson, but one of the things that is wrong with this survey is that they did a voluntary survey. So the people who read Literary Digest might tend to be Republicans or tend to be Democrats. In this case, you'd maybe say Republicans, right? And so they are the ones who responded to it, and they're the ones, of the 10 million they surveyed, only 2 million chose to send that survey back. So it was probably people who really cared about the election, and if there tends to be more Republicans who read that magazine, which would be true if you think of things that we see, like people will often say that MSNBC is the channel for Democrats and Fox is the channel for Republicans. And so there's a station you could watch that you think things are more biased towards one party or the other. I think if you want to pick neutral, people will say like CNN is the neutral site. They have Republicans and Democrats on there. Everyone has their own opinion on that, but that's what you'd look at. So if the magazine tended to have more Democrats or more Republicans reading it, those volunteer people would have more of an influence. And since you've never heard probably of Landon, obviously Roosevelt won that election, so they were very much wrong. That's why it's important for how we sample. So we want to make sure when we are doing surveys and sampling that we do it the best way possible to make sure that our results are something we can actually use. The reason for that is because the only way to really know how people think is to do a census. And a census is done in our country every 10 years. We survey every member of the population, or we try to see how many people we have and maybe what our ethnicities are, gender, household size, all kinds of information. That's not a realistic thing. It's actually really expensive for us to do the census every 10 years for our country. And if I'm running a small survey trying to figure something out, I can't spend all the money to survey every person that's in my population, which is why we need to do sampling. There are 3 types of sampling listed here. One is voluntary response. That's the one we just talked about, and that's an online or phone-in poll. You're choosing to respond to the survey. Now, people will say that voluntary response is biased, which it is. Sometimes that bias is okay. There are times where I might want to care what people ask. Like if I have voluntary response for the students in my class about what they think about something, maybe I only care about the kids who feel strongly enough to volunteer their answers. If I send a survey home to you guys and say, what do you think of flipping? How's that going? Those of you who love flipping and those of you who hate flipping are probably the ones who are going to give me that survey back. If you don't really care, you're like, whatever, it's good either way, you won't fill out that survey. And that might be okay, because maybe I don't care about people who are just neutral. I want to hear the goods and the bads. So it's not always terrible to have a volunteer survey. It's not your best option, but you can't assume it's always a wrong way to do it. It's going to be biased, but it's not always wrong to have some bias in there. Number 2 is convenience sampling. An example of that is like mall sampling. Or if I want to decide how our students feel about flipping as a high school, me just surveying my students. That's not really the best way to do it, right? Because aren't there a lot of math classes flipping? But if I wanted to be convenient, I could do it quickly in my classroom and I wouldn't have to go to other teachers' rooms to see what their students think about flipping. And then the absolute best, greatest, all-star right here, woo woo, simple random sample. That is the choose all, greatest thing you could ever possibly do for all sampling methods. Whenever possible, we choose a simple random sample. meaning we draw out of a hat, or it's the least biased. A simple random sample is me putting all the names of the kids that are flipped into a hat, pulling out however many I want to sample, and that's who I pick. Now, we'll talk about sample size as we get more into this, and that's going to lead to some bias on its own, but in general, the simple random sample is the way to go. It is the least biased way to do any type of sampling because everyone has an equal shot of being picked, and that's a really big deal. Now, you have some readings that are attached. It's the back of your notes. So I want you to pause and read that, and that's going to be something that we talk about. Well, we've kind of already talked about the volunteer and commute, so it's just an example for you to read through. And now, then we'll move on to this stuff. So pause the video, go ahead and do that reading, and then we'll come back. Now, one of the ways that we use for our simple random sample to find a simple random sample is a table of random digits. The one thing about it that we like about it is there's no pattern to that table. It's totally random. And every number or set of numbers has an equal chance of being chosen, which is really big for a simple random sample. Everyone has the exact same chance of being chosen. So, to go through, if we were going to ask what's the probability of that a digit circled in red is a 9? Well, a digit circled in red being a 9, the probability in this case is 100%, right? But in general, like because we see it circled in red, how many total digits do we have that could be single digits? The numbers 0 through 9 can be single digits, right? So of these 10 choices, you have a 1 in 10 chance of getting a 9. So my options, when I have single digits, since this is single digit, 9 single digit, my only options are 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are my options, because when I go to 10, I'm at 2 digits. There's 10 options. What's the probability that the one I pick is a 9? Well, 1 out of 10. So then when you go, what's the probability digit circled in blue is a 28? Well, 28 is one option, but think of all the numbers I have that are 2 digits. I have 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5. Can you see the pattern I have going on? All the way up to 98, 99. Now some people would say there's 99 digits, but don't forget about 0, 0. That's an option. So we have 100 options for 2 digits, and 28 is one of those options, so it's 1 in 100. What's the probability digit circled in green is 125. As you can imagine, we have the same pattern. This is 3 digits now, though. This is how we go. Keep going until we're at 998, 999. So we'd list every number in between there. So there's 1,000 options. So we have a 1 in 1,000 chance of getting the number 125. So the reason we went through that is on the table of random digits, you have a higher probability of getting a number if it is a single digit, and the more digits you add, the lower the probability of getting that number. It doesn't change the probability for each number though, and that's what makes it random. Every single one of these 10 numbers up here have the same chance of being picked. 1 in 10, 1 in 10, 1 in 10. There's not one number that happens more than the others because it's random. So that's why we use this table, because that's really important in a simple random sample. So now, you'll see on the bottom of your notes it says, conducting a simple random sample. The goal is to label each person, object, individual with a number. All the labels must have the same number of digits. So I can't go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's say there's 12 people. I would have to go 0, 0, 0, 1, 0, 2. If my biggest number is 2 digits, that's how many digits I have to use for every number. 0, 3, all the way until I get to 12, because then every single one has 2 digits. The reason I have to do that goes back to this question right here. If I make some of them single digits and some of them 2 digits, there's a different probability associated with that, which means that I no longer have a simple random sample. So that's a big deal. However many digits your biggest number is, that's how many you have to go by. So let's say that my biggest number was, let's pick something ridiculous like 10,000, okay? 1, 2, 3, 4, 5 digits. If I want to list the number 15, I have to go like this and have 5 digits. That's the number 15. So you'd number everything 1 through 10,000, which is a lot of work, right? Probably not the best way to do it. We maybe want to cut up and do a draw out of a hat. But for random digits, I could. But you have to keep your digits the same when you're looking, or else you don't have a simple random sample. So now, I have a list over here of my Block 2 algebra class. This is my dream algebra class right here. So when you look at these names, we're going to choose 3 people at random from the list. So the first thing you do is you number them, and I'm going to count how many I have. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 total students here. So then because I have a total that is 2 digits, I know I have to number all of them with 2 digits. I could start Isaac Newton with 0, 0 or 0, 1. It doesn't matter. You get to choose because either way they have an equal chance. So let's just say I'm going to start him with 0, 0. And then I'm going to go in order. I'm just numbering them down. And apparently it looks like I can't count, doesn't it? Because it's only 12. Remember there's 13 because the 0, 0 was right there. So there is 13 here. So now I'm just going to start at 101. We'll just go with the first one. We'll start at line 101 on our table. And I'm going to choose the first 3 numbers that come in. So I'm looking 2 digits at a time. So my first number is 19. I don't have a 19. Then it's 22. I don't have a 22. Then I do bridge these. So 39, 50, 34. There we go. Look at that. 5. I have a 5. So my first choice here is Henry. Henry's my first winner. Then I keep going. The next 2 digits is 75, 62, and I'm crossing these out because I need a number between 0, 0, and 12. 87, oh, 13, look at that. 13, I have a 13. Oh, I don't have a 13, I start with 0, 0. That one's out. 96, 40, 91, 25, 31, 42, 54, 48, 28, 53. I'm through the whole line and I only have one number. So I keep going. 73, 67, 64, 71, 50, 99, 40, 0, 0. Look at that. Never would have thought that one got picked, would you? Isaac Newton's a winner. There we go. And I need one more, because I asked to pick 3. 19, 27, 27, 75, 44, 26, 48, 82, 42, 53, 62, 90. Keep going. 45, 46, 77, 17, 9. Oh, look at that, 9. So my 9th one is Euclid. He's a big winner in my book. There we go. So there are my 3 choices. Now, excuse me, there's going to be times when, like in this case, I'm not going to pick 2 of the same students. Let's say they win a prize. I'm probably not going to allow for repeats. So if I would have gone through and gotten, let's say, 0, 0 again before I got Euclid, I would have just ignored that and kept going. There are times someone could be chosen twice, though, because you'll notice the 0, 0 would have come up next, wouldn't it? See that over here? I would have got that. So there's times that I can ignore that, so you'll have to kind of pay attention to that. It won't come into play a lot in our class, but it does if you continue to study statistics. So if I'm going to list the 3 people I choose at random, my first choice was Henry, and then we'll go with Isaac, and then Euclid. And you would list those. If you start at a different line, let's say I decide to start at line 113, would I get 3 different people? Probably, right? It's a random table of digits. So the fact that I start at line 101 is important. I would say that in my work, started at line 101. And it doesn't matter which line. You can flip a coin to decide which line you start on. And then that's where you just begin and you just work your way across. But you have to go in order once you start. So I ended up ending at line 103. It could have taken me all the way down if I had to pick more people. And I would keep going. So now, here are some real life situations we're just going to talk about quickly. When is it, in a real life situation, when is it okay to choose someone at random? Let's think of things that it's okay to choose random people for. How about I can choose a random person for winning a prize, right? Like if I had someone bring me a piece of cake during class and I didn't want to eat it, so I just pick at random who wants the cake. Of all the people who want it, I'll randomly pick them so I don't play favorites, right? Other things you can choose at random, maybe who goes to the office for me to drop something off. I mean, there's lots of things you guys can think of why you can choose a random person. And then when is it not okay to choose someone at random? Well, my one that really stands out for me is who you marry. I would not be happy having someone randomly pick who I marry. That would upset me, right? What else could it be? Maybe who our president is. Probably don't want to randomly pick someone out of that, right? regardless of if you're Democrat or Republican, the other person running against them is probably better than the random citizen because they at least are informed. Who gets organ donations? That's a big one. That's not random, right? That doesn't seem very fair. They have a waiting list, or who needs it? How about scholarships? Some of you would be like it if they chose that at random, and some of you would be really upset, right? Because you work hard for that. So there's lots of times it's not okay to choose someone at random, but there's many times it is. Another thing we can add up here is just to do surveys, right? That's what we're talking about. So how to survey people, choosing at random is a good way to do it. So here's how on your calculator you would want to do random numbers. It says hit math, and then you go to PRB and random int, and then you type in your lowest number you want your calculator to spit out, and then a comma, and then your highest number, and then a comma and how many. So for the problem we did with the students in my class when I had to choose 3, I'm going to go to math, and I'm going to go over to PRB, random integer, so that's number 5. And remember, we had 13 kids, so I'm going to go 0 to 13. Actually, I should say 12 then, shouldn't I? 0 to 12, and then I'm going to say we're choosing 3 of them. So now it's going to spit out those 3, 12, 11, and 1. So using my calculator, it would have done 12, 11, and 1. So let's go back to that. Oops. My calculator would have had me pick Archimedes, Nils, and 11. Pierre. That's who my calculator picked randomly. Different than what I got, because it's random. It should be, right? It'd be weird if it'd be the same 3, wouldn't it? What's the probability of that? So that's how my calculator is. So you could do it with your calculator or the table of digits. They both work. Last thing we're going to talk about is our accelerated math examples. It says, at an Ernesto's summer job at a research company, he must get a representative sample of people from his town to answer some questions about health habits. The following are ways he can collect his data. Are they representative or biased? Representative means not biased. They represent the sample. Biased, of course, means that it doesn't represent the sample. So we're going to explain. One says, randomly select people from those who agree to answer questions in return for a small payment. So we'll pick people, randomly select people, and if they agree to answer the questions, we'll give them an amount. That's slightly biased, right? Because maybe the payment, so payment, if I pay you for something, that might cause some bias, right? So payment may create bias, we'll say, huh? How about randomly select people from those whose membership to health clubs in town? Randomly select people who have memberships to a health club in town. Depending on what we were talking about, if we wanted to know about people who had health club memberships, that might not be biased. But if I was going to just survey members of Hutchinson, and I decided to just go with people who have a membership to a health club, let's say we were checking the obesity rate in our town. If I choose people who go to a health club, and that's the only people I select from, I might end up with healthier people, right? So it might be, the results would be biased towards healthy people. So since healthy people tend to go to have memberships to health clubs, so tend, how about, to have health club memberships, this is slightly biased, we'll say. I don't want to say 100% biased because I'm not really sure what they're asking for, so I want to be a little bit careful there. C, randomly select people from those who respond to a survey posted on the internet. This is an example of a voluntary response, so that's what leads to bias. Because they're choosing to go off the internet and answer this. So we'll call that biased. And then, last one, randomly select people from different addresses in each area of the town. If I randomly select different addresses from each area of town, because they said each area of town, think about if they just picked all addresses from the same area of town. Different areas of town can have different types of people, don't they? In your neighborhood, people probably that make the same income as your family live in your neighborhood. It tends to be. So we'd even be separated by income levels, by maybe people who live on the north side of our town versus the south side. Maybe they have different areas of interest. So this, because they said they're going to each area and they're picking different addresses, this is the least biased way. This is a good, of the 4 we're looking at, this is the least biased because they are randomly selecting, that's our key word, right? People from different addresses in each area of town. So that's our least biased way of getting the data. And then the last one we're going to do together, A school band has 200 sweatshirts to sell as a fundraiser. The survey shows that approximately 2 out of every 8 students purchase a sweatshirt. So 2 out of 8 purchase a sweatshirt. If there are 960 students in the school, will they be likely to sell all of the shirts? So of the 960 students, they're wondering how many do we think would purchase a sweatshirt. So I set that up knowing that 2 out of 8 tend to buy one. I'd go 8x, cross multiply here, equals 1920. When I divide by 8, I get 240. So I would say, yes, they would expect to sell all 200. Now, since the number is bigger than 200, that's why it shows that. I'm not saying they will sell all 200, right? I'm not sure. About every 2 out of 8 people buy it. That's not a guaranteed. So I say they're expecting it. If it didn't happen, I wouldn't be totally shocked, but it probably will happen, right? If they're expecting to sell 240, we think they'll all sell out. So tomorrow you're going to have some homework on this, a worksheet and a couple of objectives, and make sure if anything on here wasn't clear, you ask me some questions when you get to class tomorrow.